We jumped to chapter 4 today. Section 4.1. Properties of exponents. All right, so we're going to have a long list of properties. So leave some space in your notebook to write a list of properties. I don't remember how many there's going to be. There's a bunch of them. So we're going to have let M and N be counting numbers. What are counting numbers? One, two, three, four. Those are the counting numbers. You keep going. So another way to describe them would be whole numbers. Not quite. Whole numbers has one more number thrown in. Zero. Whole numbers would have zero thrown in. Well, they are real numbers, that's true, but there are lots of numbers that are real numbers that are not counting numbers. Like 1/2 is a real number, but not a counting number. So real numbers includes all the fractions, all the decimals, plus all the nice integers. All the 1, 2, 3, 4, 5, -1, -2, -3, so on and so forth. All right. So, property number 1. What does b to the m mean if m is a counting number? Exponents are a shorthand notation for what? Multiplying by itself. So if I gave you, for example, b cubed would mean b times b times b. If I gave you b to the 8th, that would mean b times b times b 8 times. Correct. So what does b to the m mean? B to the m means b times b times b how many times? Whatever m is. So this is b times b times b times b, where you have m factors of b. All right, and I don't think that's anything new, so I'm going to leave some space here to write the rest of the rules. For example, if I were to give you 5 cubed, I would hope everybody would know that 5 cubed means 5 times 5 times 5, which turns out to be 125. And if I gave you -3 to the 4th, you would tell me -3 to the 4th is -3 times -3 times -3 times -3, which is 27 times 9. Very good. 27 times 9. Think of it this way. What's 3 times 3? And then you get another 3 times 3, which is another 9. 9 times 9 is 81. What if I give you -3 to the 4th? Which is confusing because you read it the same way. This one we read -3 to the 4th. This one we also read -3 to the 4th. They sound the same. Are they the same or are they different? They are different. Very good.
The negative sign's not there.
Well, the negative sign is there. What you're trying to say is this exponent doesn't do anything to that negative sign. Why not? Because it's not in parentheses. And in the order of operations, what comes first? Powers or minus signs? Powers come before minus signs. So this is really, you're going to have the minus sign, and then you need to do the power. So it should be -81, correct. And that's a common one that a lot of people will miss. Okay? Or a lot of people will have this one with the parentheses on it, and they'll type it into their calculator, but in their calculator they won't type in the parentheses. And what happens on your calculator if you don't type in the parentheses? It does it the second way, because that's the way it should be done, because that's what you told it. Alright, so there's rule number 1. Nothing new there. What happens, this is going to be rule number 2, what happens if I take, say, 4 cubed, and I multiply it by 4 squared?
Add the exponents.
You add the exponents. How come? I agree, that's the right rule, but why is that the right rule? How come you add the exponents and not multiply them? I mean, after all, I'm multiplying. Shouldn't I multiply the exponents? The exponents are multiplication already. Okay, so what does 4 cubed mean? 4 times 4 times 4. So 4 cubed could be written as 4 times 4 times 4. And then I have multiply by 4 squared. What's 4 squared? 4 times 4. So putting that all back together in terms of exponents, how many 4s do I have? 5 of them. I have 4 to the 5th. So you were absolutely right. In that case, I add the exponents. So in general, if I have, let's say I had b to the 8th times b to the 5th, I wouldn't expect you to write out 8 b's and then write out 5 b's. You could if you wanted to. What I expect you to do is tell me the answer is b to the 13th. You simply add those exponents. All right, so that's rule number 2. Rule number 2 is if you have a base and you have a power, and then you have exactly the same base with a power, you add the powers. Bless you. All right, rule number 3 is kind of similar, except we're going to divide. What if I gave you 6 to the 5th and asked you to divide by 6 cubed? You subtract the exponents. That would make a lot of sense, wouldn't it? When we multiplied, we added the exponents, so it would make a lot of sense that when we divide, we should subtract the exponents. And that is correct. Why is that correct?
Because when you have 6, 5, or 5 sixes on the top, and 3 sixes on the bottom right now,
Exactly. That means I have 5 sixes up on the top, and I have 3 sixes down on the bottom, and I can reduce. I can reduce a 6 with a 6. I can reduce another 6 with another 6. And I can reduce a third 6 with a third 6. And what am I left with? 2 sixes, which is a fancy way of saying 6 squared. All right. So if I had x to the 34 divided by x to the 12, you would tell me that's x to the 22. Okay, so that's rule number 3. Back up to rule 3 here. Rule 3 says b to the m divided by b to the n equals b to the m minus n. But we have to have a little clause here for this one. B cannot be the number 0. How come for this one b cannot be the number 0? No. Oh, it would be b still, but it would be the number 0. What's wrong with the number 0? True, anything you multiply by 0, you get 0, but that's not the problem here. Because we're not multiplying, what are we doing? Dividing. When I'm dividing, can I have a 0 on bottom? No, that's the problem with it. B cannot be 0, because if b is 0, then I have the number 0 on bottom. And I can never have this number 0 on bottom. What happens when you have 0 on bottom? It's undefined. So that's why b can't be 0. B can't be 0 because we can't have division by 0. All right. Let's see, rule number 4. Sticking with our division sort of idea here. Pain to flip back and forth. I'll do it. Let's see, how about 5 to the 0. How much is 5 to the 0?
1.
I hear votes for 0.
1.
I hear votes for 1. All right, let me ask you a different question. How much is 5 cubed? It's 125. How much is 5 squared? 25. How much is 5 to the 1? 5. All right, so let me ask you. As I'm going down here on the left-hand side, I'm making my exponent get smaller by 1 each time, right? I went from 3 to 2 to 1. What's happening to these numbers over here? How do I go from a 125 to a 25? I divide by 5. And then how do I go from a 25 to a 5? Divide by 5. So if I were to write 5 to the 0, according to this pattern, the next thing I ought to do is I ought to divide by 5. What's 5 divided by 5? 1. What's that?
Just sounded like he was right.
It sounded like he was right?
Yeah.
What if I keep going? What if I go 5 to the negative 1? Well, I don't think it should be negative 5. If this pattern keeps going the same way, each time I make my exponent smaller, each time here I divide by 5. What's 1 divided by 5? 1/5. How about 5 to the negative 2? I have to take 1/5 and divide it by 5. If you take 1/5 and divide it by 5, you get 1 over 25. Which happens to be the same as 1 over 5 squared, correct? 5 squared is 25. So what's happening with negative exponents? They turn into fractions. That's correct. So somebody, when I first wrote 5 to the negative 1, somebody said negative 5. That's not correct. Negative exponents do not give negative numbers. Negative exponents give fractions. Negative exponents make fractions. All right, so going back to our list of rules here. B to the 0. What did we say 5 to the 0 was? 1. So what if I were to give you 3 to the 0? What if I were to give you 126 to the 0? 1. So B to the 0 is always the number 1. And again, that will work as long as B is not the number 0. And then rule number 5, if I give you B and I put a negative power on it, what's the negative power going to do to B? It's going to drop it down to the bottom. It's going to make it a fraction. And again, I have to have the same rule there. B cannot be 0. How come B cannot be 0? It would be undefined. I still cannot have 0 down on bottom. Okay, so some of the problems you're going to do are going to look like this. Simplify. B to the 8 times B to the 6th divided by B to the 9th. Just tell me what you would do. Do the top first, and you plus the exponents. So that's going to give you b to the 14 over b to the 9. And then you recognize that you have division. When you have division, you subtract your exponents. 14 minus 9 is 5. So your answer would be b to the 5th. All right. How about if I gave you x squared divided by x to the 8th? What would you do with x squared divided by x to the 8th? Subtract your exponents, and you would write x to the negative 6, because you always go top minus bottom. 2 minus 8 would give you negative 6. The directions will say that you are not allowed to leave your answers with negative exponents. So you need to get rid of that negative exponent. How do you get rid of that negative exponent? Turn it into a fraction. So you would write your final answer as 1 over x to the 6th.
You said because no answer can be negative.
that's just the general directions. The general directions that you're going to see in your homework. If you do homework out of the book or if you do homework online, the directions will always say, simplify, leaving your answer with no negative exponents. For some reason, the book doesn't like negative exponents as a final answer. My personal opinion, I don't see anything wrong with that. X to the negative 6. In fact, if you ever get to calculus, it's much better to have it written as x to the negative 6 than it is 1 over x to the 6. For something called derivatives and integrals, whatever those may be. It turns out having it written that way is much better than that way. So I'm not sure why, and it's not just this book, almost every algebra book I've ever seen says you're not allowed to leave your answer that way, write it that way. So we do. We follow the directions. All right, how about, we must have a hard one here. How about x to the 12, y to the 7th, times x to the negative 4, y to the 8th, divided by, let's see, x to the, I don't know, somebody make up a number for me, x to the 15th, y to the 3rd. Does it matter that you have more than one letter? Does it matter that you have x's and y's? No, what are you going to do? You're going to put the like terms together. So you're going to put the x's with the x's and the y's with the y's. So it's the same sort of idea. We simply multiply on top. What's x to the 12 times x to the negative 4? X to the 8, because you still add those powers. It's okay that that power is negative. When you're multiplying two things, you add the power. That's x to the 8, y to the 15, 7 plus 8 is 15, divided by x to the 15, y cubed. What's x to the 8 divided by x to the 15? X to the negative 7, y to the 12, and then could you put x on bottom? Yes. In fact, again, you must put x on bottom according to the directions in the book. So you would write this as y to the 12 over x to the 7 would be your final answer. Questions on that? All right, a couple more properties. Got to go back to my list here. Number 6. What if you have a negative power, but the negative power is already on bottom? It sends it to the top. Very good. How come? Turns it into a positive. Okay. So what happens? Let me give you an example here. If I have 1 over 2 to the negative 1. Let's just make it fairly simple. Oops. I hope you can see that, wouldn't it? There you go. 1 over 2 to the negative 1. That's 1 over, how much is 2 to the negative 1? A half, because 2 to the negative 1, by definition, that becomes a fraction of 1/2. Yeah, how do I take a number 1 and divide it by a fraction like 1/2? How do you always divide by a fraction? You multiply by the reciprocal. So this is 1 times 2 over 1, which is 2. So notice what this negative exponent did. This negative exponent started in the bottom. Where did this thing end up? It ended up in the top. All right, so that's rule number 6. If you have a negative exponent and the negative exponent is already in the bottom, all that happens is it moves to the top. So I kind of think of rule number 5 and rule number 6 together. All negative exponents do is an interchange top with bottom. If you have a negative exponent and you're already on top, you go to the bottom. If you have a negative exponent and you're already on bottom, you simply move to the top. Negative exponents just interchange top and bottom of the fraction. That's all they do. All right, the last couple rules here. Rule number 7. What happens if I have two things inside parentheses? And I raise both those things to a power. It's a distributive property, that's correct. The power goes to both of them. So that's a to the n, b to the n. And the exact same thing happens if you start with a fraction. If you have a fraction inside parentheses, and you have an exponent on the outside, the fraction goes to both of them. So that's a to the n over b to the n. And then I think there's only one more rule for today. We'll have some more rules next week. What happens if I have a base, and that base has a power, and then there's a set of parentheses, and there's yet another power? You times the powers there. That's when you multiply powers. How come? Correct. So again, just as an example, we could write it all out and we could show that it works. Let's do that. Let's say I were to give you four cubed, and I asked you to square it. Well, the easy way to do this is, what does it mean to square something? Multiply it by itself. So this is a fancy way of saying, take 4 cubed and multiply it by 4 cubed. What's 4 cubed times 4 cubed? 4 to the 6, because you add those exponents. So notice what happened? 3 times 2 does give me 6. So that does seem like it's the right rule. When you have a power followed by another power, multiply the powers. Questions on that? All right, let's see if we have some good problems in the book here. Seven, b to the negative 4, c to the negative 1, all raised to the negative 2, times 2b cubed, c to the negative 2, all to the 5th. How would you begin simplifying that? Any good ideas? Distribute. So I'm going to take this negative 2 and I'm going to distribute it through. Okay. How much is 7 to the negative 2? How much is 7 to the negative 2? I'm going to distribute this negative 2. That's not 49. 1 over 49. Why is it 1 over 49? Because this negative exponent is going to put that 7 down on bottom, isn't it? So I'm going to write it this way. I'm going to recognize that I'm going to need a fraction. I'm just going to put my 49 down on bottom. And I'll see what else needs to go on bottom. Okay, how about the b? How much is b to the negative 4 to the negative 2? It's 2 negatives, so what happens when we multiply 2 negatives? It's positive, so this is b to the 8th. And since that's a positive exponent, it goes on the top. B to the 8th stays on top. Okay, how about the c's? Top or bottom? C to the 2nd on top. Again, the power turns out to be positive. Negative 1 times negative 2 is positive, so we leave it on top. Pretty much the same thing here. I'm going to distribute the 5 through. I'm just going to write a fraction bar because I might need fractions, I might not, I don't know yet. How much is 2 to the 5th?
8.
No, that's 2 cubed. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Top or bottom? Top. It's got a positive exponent, 32. B to the... You got a 3 and then a 5, so that's b to the 15. Top or bottom? Top, because it has a positive power. B to the 15. C to the negative 10. So I would put that down on the bottom. That would be a c to the 10, but it goes on bottom because that one has a negative power.
So you don't put the negative 10 in there?
I have two choices. My two choices are, I could write c to the negative 10 here, or I can get rid of the minus sign and just drop the c down to the bottom like I did. Those are my two choices. Which way is better? Whichever way you like better is the better way. Personally, I like to get rid of the negatives as I go. So if I see a c to the negative 10, I'm just going to take it and drop it right to the bottom immediately. That's my choice. Other people like to keep that c to the minus 10 on top and get rid of all the minus signs at the end of the problem. Whichever way works for you is fine. All right, so I'm going to cross that out because it doesn't really belong there in this problem. But those are your two choices. Now I simplify it. I look at my numbers first. I've got a 32 on top and a 49 on bottom. Can I reduce 32 over 49? No? Nothing in common? Okay. So my final answer, I'm going to have a 32 on top and a 49 on bottom. Then I look at the b's. I've got 8 b's on top and 15 more b's on top, so that makes 23 b's, top or bottom? Top, because again the power would be positive. You simply add those exponents. B to the 13. How about the c's? Okay, I've got 2 c's on top and 10 on bottom. So I subtract my powers. 2 minus 10 would give me negative 8. C to the 8th on bottom. Because if I were to subtract, I could write 2 minus 10 is negative 8. So I could put c to the negative 8 right there. But then what do I have to do with that c to the negative 8? I've got to push it down. So final answer, I would write 32 b to the 13 over 49 c to the 8.
And that's because c times on the bottom, wire or subtract.
Correct. Another way to think of it is I have 2 c's up on top and 10 c's down on bottom. So when I'm all done, am I going to have more c's on bottom or more c's on top? I'm going to have c's on the bottom, aren't I? I only have 2 on top. I can cancel 2 c's out of the top, 2 c's out of the bottom. That's going to leave me 8 c's down in the bottom. So that's another way to think of it if you want to. All right. Time for you to do some problems. No, we're going to do problems right here, right out of the book. How about 36 and, oh, I don't know, anybody see another good one? 36 and 40. You guys try 36 and 40. See how you do. All right, let's take a look at these two. This one I saw done 2 different ways. So I'm going to do this one twice, show you the 2 different ways you can do this one. Almost everybody did the exact same first step. Negative 28 divided by 4 is negative 7. So almost everybody did that. Negative 7. And then most people did this. Most people just said, I got a b on top, I got a b on bottom, so I'm going to subtract. Negative 2 minus negative 3 turns out to be 1. A lot of people made an arithmetic mistake there. They had 5 or negative 5 or something like that. Watch your arithmetic. Negative 2 minus negative 3 is a 1. Since that turns out to be positive, the b stays on the top. You do not have to put the 1. You do not. I just put it there to emphasize that we had a power 1. And then same thing with the c's. I have c to the negative 3 divided by c to the negative 1. Again, I subtract my powers. Negative 3 minus negative 1 is negative 2. Since that turns out to have a negative power, what are we going to do with it? Put it on the bottom. And when we put it on the bottom, it turns it to a positive. Okay? So lots of little rules to remember. That's what makes these challenging. All right, now one question I have. A couple people did this. The 7. How come the 7's got a minus sign there. How come the 7 doesn't drop down to the bottom? That's right. The minus sign is in front. This is just the number negative 7. Does the number negative 7 have a negative exponent? No. In fact, what is its exponent? There isn't one, so it's really the number 1 if we don't write it. Okay? That's a common mistake I'll see. People will have a negative 7 here and they'll drop that to the bottom. It doesn't drop to the bottom. It doesn't have an exponent. Okay, the other way I saw this one done, which works just as well, again, I'm going to take negative 28 divided by 4. That's still negative 7. But then, I saw a couple people decide to do this. They didn't like these negative exponents. So if I have a b to the negative 2 and it's on top, what do I do with it? Drop it down to the bottom. So that becomes a b squared. Conversely, this b to the negative 3 that's down on bottom, it goes to the top and becomes a b cubed. Oops. That's a c right there, isn't it? And then I can do the exact same thing with the c's, can't I? The c to the negative 3, that's a c cubed on bottom. The c to the negative 1, that's a c to the 1 on top. And that way you have a better chance of doing your arithmetic correctly, because now you don't have all those negative numbers to deal with. So that's not a bad idea. It's not a bad idea to get rid of all the negative exponents right from the beginning. And then you have a much smaller chance of making an arithmetic mistake. Like I said, I saw a lot of people do negative 2 minus negative 3 and got an answer of 5. That's not correct. All right, so we're going to have the negative 7. 3 minus 2 is 1. So b to the 1. Again, I can write the 1 but I don't have to. And then the c's, 1 minus 3. Negative 2, since it turned out to be negative, we dump it to the bottom. C squared. All right, so there are actually lots of different ways to handle these problems as long as you follow the rules correctly. There's no set order in which you have to do the rules. Some people prefer to just subtract right at the beginning. Other people prefer to get rid of all the negative signs first and then deal with the subtraction. Either way will work. Completely up to you. Number 40. How to start? What do you want to do first? So you're just going to deal with the top first and combine your like terms? That's a great idea. 3 times 2. 6. B's. I got b to the 4, b to the negative 7, b to the negative 3, because you add those powers. C to the negative 1, c to the negative 8 gives c to the negative 9. Again, you add those powers. And I didn't do anything to the bottom, so I'll just write the bottom down again. Okay, now I need to make a decision. Do I want to get rid of my negative powers first? Or do I just want to leave the negatives where they are and go ahead and do the arithmetic and do the subtracting? Get rid of the negatives, okay. Well, I still think I would reduce my numbers first. What's 6 over 42? 1 over 7. And then we're going to get rid of all the negative exponents. So b to the negative 3, that goes to the bottom. The other b is already on bottom, but it's negative, so it comes to the top, b to the 5. C to the negative 9, that one goes to the bottom, that's c to the 9. What happens to that c to the 4? It stays there because it doesn't have a negative power. So again, I personally think that's a real good idea. I think it's a real good idea to get rid of all the negative signs. Much less chance of you making an arithmetic mistake after that. Alright, so when we're all done, we're going to have 1 b squared, right? 5 minus 3 is 2. And then on bottom, I've got a 7 c to the 13. There's my answer. Questions on that one?
It's just, it's kind of, it's always going to be left in fraction form like this, like, instead of like just one set on top, like how we were doing.
So you want to write it this way? 1/7 b squared over c to the 13? That's okay too. That's the same thing. You can write it that way if you want. Okay, the last thing we have in this section is an application of exponents. And that's called scientific notation. What's scientific notation? I'm guessing almost all of you have seen scientific notation before. What do you use scientific notation for?
Really big or really small numbers.
You use it as a way to write really, really big or really, really small numbers. All right. So, for example, if I were to give you 42 followed by 9 zeros, how would you read that number? 42 billion, million, trillion? That's billions. Okay. 42 billion. So how would you write that using scientific notation? You would write 4.2 times, and this is about the only time in your life that you will ever see me use x for multiply. Why do I never use x for multiply? Because x is always the letter x in my world. But right now I'm going to use x for multiply because that's the way it's always written. 10 to the, what power did you tell me? Why 10 to the 10?
Because you never move the decimal point over 1, so there's 1, and then it has 9 zeros following it, so 9 plus 1.
Correct. You simply have to count how many places you move the decimal point. The decimal point went from here to there. You count, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 places. So, when I give you a really big number, you're going to have a positive power. What happens when I give you a really small number? You're going to have negative power. So how come? What's 0.0052? Well, I could tell you that that's the same as 5.2 divided by 1,000. Because I move over 3 times. That's 5.2 divided by 10 cubed. So to make tiny little decimals, we're actually dividing by powers of 10. But generally we wouldn't write it this way. We would write it as 5.2 times 10 to the negative 3. Okay? So really big numbers are going to have positive exponents. Tiny little decimals are going to have negative exponents. And then here's where this becomes useful. What if I tell you I want to take 36 followed by 12 zeros, and I want to divide it by 0.000002. I'm going to convert both of them to scientific notation. That's correct. So how do you write 36? I think that one's trillion. How do you write 36 trillion in scientific notation? 3.6 times 10 to the 3, 6, 9, 12, 13. Now notice, some people would write 36 times 10 to the 12. Is 36 trillion equal to 36 times 10 to the 12? Yes, but that's not scientific notation. In scientific notation, this number in front always has to be smaller than 10. So this number in front should be between 1 and 10, always. So if you write 36 times 10 to the 12, it's not that they're not equal, it's that you didn't write it in scientific notation. And then we divide by 2 times 10 to the, that would be negative 6. Here's the answer. What's 3.6 divided by 2? That's 1.8 times, and here's where our exponents come into play. What's 10 to the 13 divided by 10 to the negative 9? I'm sorry, 10 to the 13 divided by 10 to the negative 6. Not 10 to the 7th. 10 to the 19th. You have to take 13 minus negative 6. That becomes 13 plus 6. That's 10 to the 19. So scientific notation makes multiplying and dividing really big and really small numbers pretty easy. You just got to deal with the little numbers out front then you either have to add or subtract your exponents depending if you're multiplying or dividing. Questions on that?